Hello students, आप लोग कैसे हैं? Hope you all are staying fit and studying on a consistent basis, right? So today we'll be discussing about instruments. I'm talking about measuring instruments. So you are well aware that experiments and observations, they form the basis or the foundation of science, particularly in physics. And during experimentations, we require some devices, we require some apparatus so as to measure certain physical quantities. The basic instrument which we make use of in daily life or in laboratory is a meter scale. Now it is used to measure small distances, that is up to one place of decimal accurately, because it can measure accurately only up to 1 millimeter or 0.1 centimeter. Right? It has got its certain limitations. So vernier calipers, in this session we'll discuss about vernier calipers. It is an instrument which is more sensitive than that of a meter scale. It can measure accurately up to 2 places of decimal. Right? So before we start talking about the errors, the least count, then the correction, how to note down the reading using this instrument known as vernier calipers. First and foremost, we need to understand the description, the physical characteristics of this particular instrument. So student, I have used a clipping from Edunovis, and I will request you to watch this short clipping very carefully, and thereafter we will proceed with our discussion. So have a look.
Vernier calipers is an instrument which is based on the principle of vernier and is used to measure small lengths or distances very accurately. It is much better than that of a meter scale. It is more sensitive than a meter scale. And these are the jaws known as the calipers. It is used to hold firmly an object. It can be used to measure the diameter of a sphere. A vernier calipers was invented by Pierre Vernier. It consists of a main scale which is made up of a steel and consisting of fixed jaw at one end. It is graduated in centimeter and millimeter at one edge and in inches and its fractions at the other edge. It also consists of a movable scale which is known as the vernier scale. It can slide freely along the length of the main scale and can be clamped at any position with the help of a screw attached to it. Normally a vernier scale has 10 divisions graduated on it. These are the two jaws which are known as the external jaws, and these two jaws are used to hold an object firmly. It can be used to measure the diameter of a sphere or a cylinder. These are known as the internal or the upper jaws. These jaws can be used to determine the internal diameter of a hollow cylindrical body. This is a thin metallic strip which is attached to the vernier scale on the back side of the steel bar. It is used to measure the depth of a hollow vessel such as a calorimeter or a cylindrical body.
Students, I hope you must have watched the short clipping regarding the description of the vernier calipers. Here I must mention that this short clipping was taken from Edunovis, right? So I hope you have understood its the construction part and the types of scales which are there in a vernier calipers, the main scale, the vernier scale which is the movable one, right? And before we discuss about the types of errors which a vernier calipers may possess and regarding its correction, we need to understand a very important topic of least count. In the case of vernier calipers, this least count may also be termed as vernier constant. It may be termed as a vernier constant. It may be represented by VC. Least means minimum. So basically students, it is the minimum measurement which an instrument can measure most accurately. For example, in the case of a meter scale, it's like this, 0, it is divided into 10 equal divisions. Okay, 10 equal divisions. So 1 division is equal to 1 millimeter. So 10 millimeter will constitute 1 centimeter. It's a centimeter scale, right? So this is the minimum measurement which a meter scale can measure most accurately. And therefore, the least count of a meter scale would be 1 division of the main scale, which is 1 millimeter, which is equal to 0.1 centimeter. So, what I mean to say is that this instrument, which is the scale, can be used to measure accurately only up to 1 place of decimal. Right? If I ask you to measure a length of 2.36 centimeter by using this instrument, you can never draw a line segment of exactly 2.36 centimeter, because this instrument will have a drawback that it can measure accurately only up to 1 place of decimal. So in order to have more accurate measurement, say in order to measure accurately up to 2 places of decimal, we make use of vernier calipers, which not only possess the main scale, but as we have discussed in the clipping, it also consists of a movable vernier scale. So how to find out the least count of a vernier scale? And here I must mention, the smaller the least count of an instrument, the greater will be the sensitivity of that particular instrument. The more preferable, the more accurate the measurement taken by that particular instrument, right? So let's consider the least count of a vernier calipers, least count or vernier constant of a vernier calipers. Now students, we are aware that 10 vernier scale divisions coincides with 9 main scale divisions. In laboratory, the vernier calipers so available are having this configuration. The movable scale is the vernier scale, which will have 10 equal divisions. And when both these zeros coincide, then you can check 10 vernier scale divisions will coincide with 9 main scale divisions. So what I mean to say is that 1 vernier scale division, it would be equal to 9 by 10 main scale division. And main scale division, it's a centimeter scale, right? It is divided into 10 equal parts. So each part will have a measurement of 1 millimeter. So 1 main scale division, it will be equal to 1 millimeter or 0.1 centimeter. So students, least count or vernier constant of a vernier calipers is defined as the difference between the main scale division and 1 vernier scale division. So the formula for the least count is 1 MSD minus 1 vernier scale division. This is the formula to find out the least count or the vernier constant of a vernier calipers. Now let's substitute the value and we can easily get the least count. So 1 MSD minus 1 VSD can be written as 9 by 10 MSD. So it will be equal to 1 minus 9 by 10 main scale divisions. 1 minus 9 by 10 is 1 by 10 main scale divisions, which in turn is equal to 1 main scale division is equal to 0.1 centimeter. 0.1, it's in centimeter. So as a result, the least count or the vernier constant of a vernier calipers is 0.01 centimeter. This is the least count of a vernier calipers in which 10 equal vernier scale divisions coincides with 9 main scale divisions, right? So after discussing this topic of least count, now I will show you or I will illustrate the different types of errors which the vernier calipers can suffer from and how to correct those errors. We are talking about the correction of positive errors and correction of negative errors. So students, please watch this short clipping.
When the lower jaws A and B are made to touch each other, the zero of the vernier scale may or may not coincide with the zero of the main scale. We may have the following three cases. In this diagram, it is the case of no zero error, when the zero of the vernier scale coincides with the zero of the main scale. In this case, the instrument is said to be free from the zero error. In the second case, which is the positive zero error, the zero of the vernier scale lies to the right side of the zero of the main scale. It is as shown in the figure. In this case, the zero error is said to be positive. In this case, the measured length will be greater than the actual length. So in order to correct this error, the positive zero error is to be subtracted from the measured value. And the third is the negative zero error. If the zero of the vernier scale lies to the left side of the zero of the main scale, then the zero error is negative. This is again as shown in the figure. In this case, the measured length will be less than the actual length. And that is why, in order to eliminate this negative zero error, this is to be added to the measured value. Now, how to correct the zero error and how to calculate the zero error and how to do the zero correction. In this figure, sixth division of the vernier scale coincides with one of the main scale division. Right? So in this case, the zero error would be 6 times the least count, which is 6 into 0.01 centimeter. So the zero correction would be negative of this, 0.06 centimeter with negative sign. Similarly, in order to calculate negative zero error, in this case, let the fourth division of the vernier scale coincides one of the main division of the main scale. In such a case, the zero error would be given by minus the total number of divisions in the vernier scale minus the division coinciding multiplied by least count. So in this case, it would be minus 0.06 centimeter. And in order to correct it, the zero correction will be plus 0.06 centimeter.
Students, this diagram illustrates the measurement of the diameter of a circular disc. Do concentrate on this diagram, students. It has got two scales. The upper one is the main scale and the lower one is the vernier scale containing 10 equal divisions. You can see the diameter of the circular disc will lie between 2.2 centimeter and 2.3 centimeter. It is because the zero of the vernier scale lies between 2.2 and 2.3. So the main scale reading would be 2.2 centimeter. While the 8th division of the vernier scale coincides with one of the division of the main scale. So n would be equal to 8. Therefore, observed value would be main scale reading plus vernier scale reading. Vernier scale reading is n multiplied by the least count. So as a result, the observed value would be 2.28 centimeter. Now let us consider the instrument to be having positive zero error. In this case, zero of the vernier scale lies to the right side of the zero of the main scale. And suppose the 6th division of the vernier scale coincides with one of the main scale division. Then the zero error would be 6 times least count, which will be 0.06 centimeter. Now students, since this instrument is having positive zero error, therefore the measured length will be greater than the actual length. So in order to compensate this, the value of 0.06 centimeter is to be subtracted from the observed value. So the zero correction would be minus 0.06 centimeter. Look at the observation table. Observed value is 2.28 centimeter, while the corrected value is obtained by subtracting 0.06 centimeter from 2.28, which will give us 2.22 centimeters. Now, if the instrument is considered to be having negative zero error, then obviously zero of the vernier scale will lie to the left side of the zero of the main scale. And suppose the 4th division of the vernier scale coincides with one of the main scale division. In this case, the zero error would be given by subtracting the 4th division from 10, which is the total number of divisions in the vernier scale, and then multiplying it with the least count, which in this case would be 0.06 centimeter. So in this case, the measured length will be less than the actual length. So as to compensate this thing,
the value of 0.06 centimeter is to be added to the observed value. So now the corrected value would be 2.28 plus 0.06, which is 2.34 centimeter. And students, if the vernier calipers do not possess any zero error, then the observed value would be equal to the corrected value. No correction will be required in that case.
Okay students, now since we have discussed vernier calipers in detail, now we are in a position to solve these numericals based on vernier calipers, right? Let's discuss the first question. First question is, n divisions on the main scale of a vernier coincide with n plus 1 divisions on the vernier scale. If each division on the main scale is of A units, determine the least count of the instrument. Now we are aware that least count is also known as vernier constant, and it is given by 1 main scale division minus 1 vernier scale division. This is the formula for obtaining the least count of vernier calipers, right? So here it's given that main scale of vernier coincide with n plus 1 divisions of vernier scale. It coincides with n divisions of main scale. Therefore, one vernier scale division, it would be equal to n divided by n plus 1 main scale division. So one vernier scale division is equal to n divided by n plus 1, and one main scale division, it's given to be A units. It's given, students, each division of the main scale is given to be A units. So therefore, one main scale division is equal to A units. One main scale division is given to be A units. Right? So let's substitute this value over here and we should get the result. Therefore, least count or vernier constant would be equal to 1 MSD minus 1 VSD. VSD is n over n plus 1 MSD. So, 1 minus n over n plus 1 into 1 MSD. And one main scale division is equal to A unit. So, what you get is n plus 1 minus n divided by n plus 1 multiplied by A. So, that will give us A divided by n plus 1. So, this will be the answer of the first part, right? So, the least count of the vernier calipers under consideration, it would be A divided by n plus 1. A is one main scale division. It's given in the question. Now, students, let's try to attempt the second question. Just read the second question. A vernier calipers has 10 equal divisions on the main scale, and one main scale division is equal to 1 millimeter. The main scale division reading is 12, and third division of vernier scale coincides with the main scale. What is the measured length? Measured length is to be calculated, right? So, main scale division reading is reading of main scale. Reading of main scale. It is 12 divisions. And one division is equal to 1 millimeter. So 12 divisions would be equal to 12 millimeter. So it would be equal to 1.2 centimeter. So that's the reading of the main scale. Now look, third division of vernier scale coincides with the main scale. So n is the number of divisions of the vernier scale coinciding with any division of the main scale. So that is given to be 3. So therefore, vernier scale reading would be, vernier scale reading, it would be 3 multiplied by least count. Least count would be 0.01 centimeter. Right? For a normal vernier calipers, the least count is 0.01 centimeter. So, what we get is main reading, measured length. It would be equal to main scale reading plus n times least count. This will be the vernier scale reading. This is the vernier scale reading. So what you obtain is main scale reading is 1.2 centimeter plus n is 3 multiplied by 0.01. So what you get is 1.2 plus 0.03. So that will give us 1.23 and we are expressing the length in centimeters. So this should be the measured length, right? So that is how you need to proceed for question number 2. It's very simple based on the basic facts which we have just now discussed previously. Okay, third one. This is a good one. A vernier of a circular scale is divided into 30 minutes, actually 30 divisions, which coincides against 29 main scale divisions. If each main scale division is half degree, then find the least count. So it is given one main scale division, it is given to be half degree. And it is given that vernier of a circular scale is divided into 30 divisions, which coincides against 29 main scale divisions. Means also given is 30 vernier scale divisions is equal to 29 main scale divisions. Therefore, one vernier scale division, it would be equal to 29 by 30. 29 by 30 main scale division. Right? So, what we get is least count, which is also known as vernier constant. This we are aware of. Least count is given by one main scale division minus one vernier scale division. Right? So, let's substitute the value. So, it is 1 MSD minus, in place of VSD we can write 29 by 30 MSD. So what you get is 1 minus 29 by 30 MSD, main scale division. So when we solve, we get 1 by 30 main scale division, which is equal to 1 by 30 into 1 main scale division is given to be half degree. It's given 1 main scale division, it is given to be half degree. Therefore, in degrees, it will be 1 by 60 degree, right? Or this is the least count of vernier constant in terms of degree. It can also be rewritten as 1 by 60 degree. 1 degree is 60 minutes. So it can be written in minutes as well. So it is equal to 1 minute. So least count of the vernier scale in this case is 1 minute or 1 by 60 degrees, right? It can also be written as 60 seconds. 1 minute is equal to 60 seconds, right? Okay, last question is left. It is, a vernier calipers is found to have a negative zero error. Remember students, negative zero error means when the two jaws are in contact, then what happens is the zero of the vernier scale lies to the left of the zero of the main scale. And negative zero error means it will give a value which would be less than the actual value. So in order to correct it, this error needs to be added to the measured value so as to compensate it, isn't it? So let's discuss the last question. Vernier calipers is found to have negative zero error. When the jaws are in contact, the 8th division of the vernier scale is found to coincide with some MSD, right? So n is equal to given to be 8. So we are supposed to find out first negative zero error. So remember students, here we are supposed to consider the vernier calipers to be the one which we make use of in lab, having least count of 0.01 centimeter. In lab, the vernier calipers which we use are having 10 equal divisions in vernier scale, which coincides with 9 main scale divisions. So the least count is found to be 0.01 centimeter. So in case the least count is not given, consider it to be 0.01 centimeter, right? So one more thing students, in case of negative zero error, suppose in this case the 8th division of the vernier scale is coinciding. So how to find out negative zero error? this 8 is to be subtracted from the number of divisions in the vernier scale, which is 10. So it will be 10 minus 8 multiplied by the least count. This is a very, very important step. In case of positive zero error, n should be multiplied simply by LC, least count. But in case of negative zero error, the number of divisions of the vernier scale coinciding with subdivision of the main scale is to be first subtracted by the total number of divisions in the vernier scale, which in this case is 10, right? So it will be given by 2 multiplied by least count. Least count of a normal vernier calipers is 0.01 centimeter. So it is 0.02 centimeter. It is negative zero error, right? It is negative zero error. This is negative zero error. Now, as I told you, an instrument having negative zero error will give the measurement which is less than the actual value. So, in order to compensate this error is to be added to the measured value so as to get the actual value, right? Therefore, zero correction, the corrected value. Correction would be plus 0.02 centimeter. Means this value of 0.02 centimeter is to be added to every measured value so as to obtain the correct value. In case of positive zero error, it is to be subtracted from the measured value. In case of negative zero error, it is to be added to the measured value, right? So I hope you have understood this concept of vernier calipers. Clear? So students, do watch this video time and again, and I am very, very sure I am able to convince you each and every minute details of this particular instrument. So good luck and study very well. Thank you.